In this section we're going to simplify radicals. But before we get to simplifying radicals, there's a few concepts that we need to cover. The first concept is perfect squares. Perfect squares are numbers that we know their square roots. Their square roots come out to be integers. To come up with a list of perfect squares, we're going to take numbers and square them. Like 1. 1 squared is 1. So 1 is our first perfect square. 2 squared is 4. So 4 is our second perfect square. 3 squared gives us 9, and so on. These numbers that you just wrote are the first 12 perfect squares. For this class, you're going to want to memorize these perfect squares so that you're familiar with them and you can use them to simplify radicals. The second concept we're going to cover is we're going to look at what happens when we take the square root of two things that are being multiplied. So if I have the square root of a times b, I can actually distribute that square root to each term, keeping the multiplication between those two terms. So the square root of a times b turns into the square root of a times the square root of b. Similarly, if I have the square root of a fraction is really two numbers being divided. I can distribute that square root to my numerator and my denominator, keeping division between those two terms. So the square root of a over b turns into the square root of a over the square root of b. Let's look at example 1 and simplify the square root of 80. Well, the first thing I want to do is I want to rewrite 80 as two numbers being multiplied. So to keep my equality, I need to make sure that whatever two numbers I write here and here multiply to give me 80. Well, I can pick 2 and 20, or I can pick 1 and 80, or I can pick 4 and 20. But what I also want to do is I want to find the biggest perfect square that divides 80. So if I want to find the biggest perfect square, I'm not going to start with the small numbers, I'm going to start with the big numbers. So I'm going to take 80, and I'm going to try dividing it by all of these perfect squares that are smaller than 80. So 80 divided by 64. Doesn't come out evenly, so 64 does not divide 80. I'm going to go to my next smallest perfect square, 49. Moving on to my next smallest square. And I'm going to keep going down my list of perfect squares until I find the biggest perfect square that divides 80. There it is, it's 16. I can rewrite 80 as 16 times 5. So I've kept equality. 80 is rewritten as 16 times 5. But what I've been able to do is rewrite it as two numbers being multiplied, which means I can distribute that square root to each number, keeping multiplication in between. So I'm going to rewrite it as the square root of 15, or square root of 16 times the square root of 5, which turns into, well, I know what the square root of 16 is. 16 is a perfect square. The square root of 16 is 4. That's the reason I picked a perfect square, is I know its square root. And the square root of 5, I'm just going to leave as the square root of 5. So my final answer simplified is 4 square roots of 5. Example number 2. I have 5 square roots of 20. I'm going to rewrite 20 as two numbers being multiplied, where my first number is a perfect square. And I want to pick the biggest perfect square that divides 20. So if I look at my list, 9 does not divide 20, 16 doesn't divide 20, but 4 divides 20. I can rewrite 20 as 4 times 5. which allows me to distribute that square root to each term underneath the square root, keeping multiplication in between. And I know what the square root of 4 is. That's why I picked a perfect square. The square root of 4 is just 2. And I got to keep this 5 out front. The question is, does this become 52? Well, the operation between this 5 and this square root is multiplication. So I want to keep it multiplication all the way through. So this is really 5 times 2, which gives me 10, times the square root of 5. Now at this point, I'm done. I can't multiply these together because they're unlike terms. This 10 is just an integer, and this 5 is stuck underneath a square root. Looking at example 3, I have 2 square roots of 3. And if I remember, between this 2 and the square root, there's multiplication. And I have 4 square roots of 12. And between this 4 and the square root is multiplication. So in reality, I have 1, 2, 3, 4 terms that all have multiplication between them. So when I rewrite it, I want to make sure that I have 1, 2, 3, 4 terms with multiplication between them. I have 1, 2, 3, 4 terms. And since I have multiplication all the way across, I can use the commutative property and change the order in which I multiply. I'm going to keep my first number 2 the same. I'm going to keep my last number, the square root of 12, the same. The two numbers that I'm going to change are this 4 and this square root of 3. Now it doesn't look like I've done much, but I've rewritten it in such a way that I can now multiply this 2 and this 4 together to get 8. And since these numbers are both square roots, I can also multiply square roots together. If I look at this property right here, if I start right here, I can multiply 2 square roots together by combining them underneath one square root symbol. So I can use this property backwards. The square root of 3 times the square root of 12 can be rewritten as the square root of 3 times 12. Well, now I can do this math right here. 8 times the square root of 3 times 12 is 36. Well, now I got to simplify the square root of 36. So I look at my list of perfect squares and I find out that, well, 36 is a perfect square. So I know that this is just 8 times 6. And I can do that math. 8 times 6 is 48. At this point, flip your paper over, do examples 4 and 5 while watching the second part to this podcast.